Hey everyone! In this video, we're going to review and practice solving equations with multiple steps. So remembering that we will be doing that by undoing operation using what we call inverse operations. So the directions say to solve each equation for the indicated variable. So just remember, a variable is only a placeholder for an unknown value, and it can be represented with any letter. So in this case, we'll solve for x. In this case, we'll solve for r, so on and so forth. And one thing to remember is that although each problem we do will look different and will have, different ways of undoing the operations with the inverse operations, there is one common goal that all these problems have, and that is what the end should look like. At the end of every single problem, you should have the variable by itself being equal to some number that we are going to undo the operations to find. So in this case, you would have like x equals a number. In this problem, you will have r equals some unknown number, so on and so forth. And if you keep that goal in mind, it's helpful to seeing what needs to happen. So if I want x to be by itself, just like I have here, we might start thinking about how do I get rid of this, this, and this? Because if all of that were gone, x would be alone, right? Same thing in this problem. If I want r to be by itself, we've got to get rid of these things to make that happen. And when you're doing this, we're going to consider the two sides of the equation and kind of hope to move anything that's not the x over to the other side, which is where you'll get the number from because all the numbers are going to move to the right and our x will stay by itself isolated on the left. Okay, general thought process, although each set of problems you might go through a different set of steps to get there. Okay, so in this particular case, I noticed that the x is first and foremost distracted, being bothered by this fraction sign here, so it's over 4. And I first want you to remember that all a fraction is division. Okay, so this says take 8 minus x and divide it by 4, and you'll get -2. The reason I related to division is that tells us how you undo that. What is the inverse of division, or the opposite, the operation that undoes it? And hopefully you should be thinking that's multiplication. And that tells you the step you need to take to solve this. And the reason I reference this first is because everything's being affected by the divided by 4, so we definitely want to get rid of that first. Whereas this problem, only the r is being affected by the divided by 9, so we might actually wind up moving this -5 over first. But this problem, everything's being divided by 4, so let's undo that first. Then the question becomes, how do you undo divide by 4? And the answer is you would multiply by 4. Those are inverse operations, they undo each other. That's one way you can think about it. You can also think about it as 4 over 1 times 1 over 4 is 4 times a fourth is just 1. So that would cancel out. Whatever you do to one side of the equation, though, you always do to the other side of the equation. So I'm going to multiply the right by 4 as well. Okay, since those are inverse operations, they cancel out. All that you have left is the 8 minus x. So essentially what you've done is you've gotten rid of that fraction one step at a time. So -2 times 4 is -8. Okay, again, you want x to be by itself on the left here. So now we need to get rid of the 8, the positive 8, right? This is positive 8 that's on the left side here. Okay, this is a positive 8. So oftentimes I'll get students saying, okay, I need to move this over. Maybe I'll add 8. And a way to check that right away is, does 8 plus 8 cancel out? No, it does not, because 8 plus 8 is 16. Does 8 minus 8 cancel out? Yes, it does, because 8 minus 8 is 0. So that's what you want to do here, and whatever you do to one side, you're going to do to the other. So this is 0. That's why it's by itself. It's canceled out. Okay, what we carry down here is not just x. It's actually a minus x. Don't lose that subtraction sign. It means -x. And then -8 minus 8 is like you're $8 in debt, and you lose $8 more. So now you're even more in debt. You have -$16. Okay, sometimes students look at this and say, I think that that's all I need to do. The x is by itself, but that's not the case. There's actually a 1 in front of the x. So if x is alone, it's 1x, but it's really a -1. And in order to be fully isolated, it needs to just be x, not -x. So this is -1 times x if it's the coefficient. How do you undo multiplication? You would divide both sides by -1. Okay, so -1 divided by -1 leaves us with +1, which would just be x by itself. -16 divided by -1. 16 divided by 1 is 16, but a negative divided by a negative is a positive. So essentially, those signs kind of flip there because you're dividing by a negative. So our final answer is x equals 16, which the nice thing about any solving problem is you can always plug this back into the equation to confirm that it works. So I know that this was unknown before, now it's known. Let's substitute the 16 in and see if we get a true statement. Okay, so 8 minus 16 is negative 8, divided by 4 does equal negative 2. So that works, we checked it, we know we did it correctly. It's a nice thing that you are able to do. I'm gonna pause the video and have you try the second one on your own. So solve r divided by 9 minus 5 equals negative 3, which really says what unknown number, when you divide it by 9 and then take away 5, will give you negative 3. So you can kind of think that through as well. A little bit different than the last one because the division doesn't apply to both things, right? You're not dividing the minus 5 by 9 as well. So you might do it in a slightly different order, but similar ideas. So I'm going to see what you can come up with, and I'll come back with the answer. No peeking. Okay, if done correctly, you should get r equals 18, and you can look at my work for why that is. You'll notice I did a different first step. I did not get rid of the fraction first. I actually moved this minus 5 over, like I mentioned earlier, first. So this is minus 5 or subtract 5. You undo that with add 5. And the reason I did this is because it isolates the term with the variable in it. And then divided by 9 only affects the r, not the 5. So since the 5 is just kind of on its own, you can move it over and collect the numbers first. Okay, so then I have r divided by 9 by itself. That's equal to 2, because 5 plus negative 3, or negative 3 plus 5 is 2. Or you can think of it as 5 minus 3. Okay, so when you want to get rid of that divide by 9, you undo division with multiplication. We multiply both sides by 9, right? These guys cancel out here. 2 times 9 is 18. You can always check your final answer, as I mentioned before, by plugging this in for r, right? So if I take 18 and I plug it in for r, we would then have 18 divided by 9 minus 5. Does that equal negative 3? Well, 18 divided by 9 is 2. 2 minus 5 does in fact equal negative 3, so we know we've done it correctly. You should always know if you got the problem right because you can plug it back in, since originally it was an unknown and now it's not an unknown, right? You know the value of the variable is 18. Next problems. These problems look a little bit different. We've got a couple of different things that are going to come up here. So in this third problem, you still have two sides of the variable, two sides of the equation, but you actually have variables on both sides of the equation. So that makes this different, right? In the previous problems, you only had one variable term. And in this problem, we see that there are some parentheses. So you might be thinking distribution, multiplication. That makes this problem a little bit different. So how do we tackle them one at a time? Let's start with this one. Okay, remember your end goal. If you remember your end goal, all these problems are essentially the same, just done in a different order. So at the end of this, you want to solve for y, and you want y to equal a number. And that's the format we need to get this into, which means we need to get all of our variables on one side and all of our numbers on the other side. It doesn't matter which side necessarily, but that's the end goal. Okay, so what I might do first is try to get all the variables on one side. So maybe I will take the minus 3y and move it over here so all the y's are on the left. So you have to ask yourself, how do you undo minus 3y? You got to cancel that out. Okay, so since it's subtraction, you want to add it, 3y, to both sides. Okay, so minus 3y and plus 3y, the reason that works is they cancel out and give you 0 y's, right? It's like you're 3 y's in debt, but then you earn 3 y's, now you have no y's. Okay, so that would cancel out and give you 0, and it would move over here. The 37 has been unaffected because those aren't like terms. You're just combining the y's on the left. We call that collecting like terms. So we have minus 5y plus 3y. It's like you're $5 in debt, but then you gain 3 y's. You're not out of debt yet, but you only have $2 in debt left. These have canceled out, so you're just left with 5 on the right side here. Once you combine those like terms, you collect those like terms, this looks like a regular two-step equation where you want to move the number over and then you could isolate the y. So keep in mind here what I set up above is you got to move then the numbers to the right side or the other side of the variable. So if you add 37, those won't cancel out. but 37 minus 37, that's 0. So there would be nothing left over here, but you do the same thing to the other side, so the 37 moves over. So there's no 37 left here. That 2y minus 2y, better yet, carries down. Don't lose the sign. It's part of the problem. You're losing 2y's, you're not gaining them. It's got to stay that way. So now you have $5 and you take away $37. How many dollars do you have? Well, you're definitely in debt. You have 5 and you take away 37. You have minus $32. Okay. Now you have the minus 2 in front of the y. You have to get rid of that. So in order to do that, it's minus 2 times y. How do you undo multiplication? You would divide both sides by negative 2. To get y is, well, just remember a negative divided by negative is a positive. 32 divided by 2 is 16. So it's going to be positive 16, your final answer. And as before, you can always plug that in for both y's and make sure you get a true statement to confirm that that is correct. Okay, for the sake of time, we're going to go on to this last problem here when you have distribution, but you can try that on your own. So in this next problem, you've got parentheses. That makes this different. You have minus 9. We need to remember what that means. So at first glance, you could simplify this expression by doing what we call distributing. So you could take the minus 9, and when you distribute, what you're doing is you are multiplying the minus 9 to the 2t and the minus 1. The parentheses, just group it together and say multiply to both things. That's option 1. I should even write that. Option 1 is to distribute, which is a totally valid and mathematically correct option, but may take you a little bit longer than option 2. So option 2, you recognize that distribution is a form of multiplication. So we could do that, or we could choose to undo multiplication, because distribution is just multiplication. Oh, is that going to fit? There we go. Okay, so you can undo multiplication. So how do you undo multiplication with division? So instead of distributing, you can divide both sides by negative 9, because negative 9 divided by negative 9 is 1. So you would just have 1 times 2t minus 1. And if I do that, that makes it a little bit simpler because you're getting smaller numbers out of it. Okay, so those would cancel out because it's just 1. You'd just be left with 2t minus 1 since those canceled out. And 18 divided by negative 9 is negative 2. And then you just have a two-step equation to solve. Again, you could have distributed, but if you do that, you're going to get the equation negative 18t plus 9 equals 18, which is totally fine. And it's also a two-step equation, but these numbers here are bigger than these. So you have to choose which one. Either one will get you the same answer at the end. So with that said, no matter which method you choose, I'm going to have you try solving this from here and see what you get for t. Get t by itself, and I'll come back with the answer shortly. Okay, if done correctly, you should get a fraction, and it's okay to get a fraction. T is negative 1/2, which all I did was I moved the minus 1 over by adding 1 to both sides. Okay, so that canceled out, and you got negative 1 here. Then you divide both sides by 2 to get t is negative 1/2. And fractions are okay. They're just numbers, just like any other number, even if we don't like them. Okay, so two options for how you would do this problem. Either way, you get t is negative 1/2. You choose what you like better. Okay, otherwise, that's how you solve multi-step equations. There are lots of different kinds of equations that have multiple steps, and they're all tackled a little bit differently. But if you remember that at the end, you just want to have variables on one side and numbers on the other, they're really not that different. Just different ways of going about it, different inverse operations you use, depending on what you see. Okay, so take the time to evaluate each problem, and if you have any questions, definitely let me know. Otherwise, have a good night.